Hi, welcome back to this section, lambda expressions or nameless functions. What are we going to learn in this section? First, we're going to take a look at statements and expressions and learn to tell the difference between the two, which is very important in functional programming. And then we're going to take a look at lambda expressions, which is a functional way to define functions. Then we're going to move on to and or. Those are the common and or operators, and you probably think that you understand them completely, but there's more to it than you think. And finally, we're going to take a look at if expressions, which is the functional counterpart to the more commonly known if statement. Now, let's start with the video on the difference between statements and expressions. So what are we going to cover in this video? Well, we're first going to take a look at statements, and then going to take a look at a couple of expressions. And we're going to look at a list of common statements and their expression alternatives. What is a statement? A statement is an instruction to the Python interpreter, essentially. There are many statements that you are undoubtedly familiar with. For example, an if statement, for loop, a for is a statement, a def with which you define a function is a statement, class with which you define a class is a statement, etc. All of these are procedural statements. Now, you can recognize a statement very easily because a statement doesn't evaluate to something, right? A statement is just an instruction and it doesn't have a return value, so to say. So in other words, if you cannot print a result of something, that means that it's a statement. And then we have expressions. Expressions are very important in functional programming, and expressions are basically everything that evaluates to some value. So basically, if you can print a result, then it's an expression. And very important to know in Python is that also function calls are expression, right? Even if you have a function that doesn't return anything explicitly, it always returns the value none. So every function has a return value and is therefore an expression that you can print out. Let's take a look at what statements look like in practice, right? So that you can recognize them. Now, a very trivial but very important statement is the assignment, right? And procedural programming relies heavily on assignment. So for example, x equals 0 is an assignment and x plus equals 1. So an assignment plus an addition is also a statement, right? And functional programming in principle, in its purest form, doesn't use statements and in other words, therefore also doesn't use assignments, right? Now, then we have the if statement. Again, very, very common, of course, in procedural programming. So if statements and the associated elif and else statements are the main way in which you do implement conditional branching, right, in procedural programming. So with which you control the flow of your experiment. And these are also statements, and you cannot use them in functional programming, at least not in the purest form of functional programming. But we will see that if statements have a functional counterpart, namely if expressions. Another class of statements are loops. So for example, a for statement for a for loop is a statement, right? And a while statement for a while loop is also a statement. And the associated things like break and continue, they are also statements. So all of these things are not allowed in the purest form of functional programming. And we will learn that there are actually functional, expression-like alternatives to using these kinds of explicit for and while loop. Now then we have function, generator, and class definitions, right? So you define a class by simply putting the word class in front of it, and the def for a function or a generator, right? A generator, if you're not familiar with a generator, is simply a function that instead of using the keyword return, has the keyword yield in it, which temporarily suspends the function and allows you to pick it up later. But all of these are statements. Def, class, pass, return, and yield are all statements that you cannot use in functional programming. And we will see again that there are functional alternatives, most notably the lambda expression, which we will deal with extensively in this section. And then there are a bunch of other statements. For example, the import statement, the assert statement. The assert statement, you can put parentheses around the thing that you want to insert, which makes it look very much like a function call, but it's not. It's a statement. There's the pass statement, right, which does nothing. The delete statement, which removes a variable from the namespace or removes an item from a list, etc. We have the try except statement and the associated raise statements and the with statements. Now, all of these, you've probably seen them in real life, right? All of these are statements, and there's nothing wrong with statements, obviously, but the main point is that most pure form of functional programming, you don't use any of these statements. You rely purely on expressions. Now, so what is an expression? An expression, as I already said, is basically everything that gives you value that you can print out. And we're going to see a lot of kinds of expressions in this course, but just to give you a flavor, here's a selection. So basically, this 10 times 2 is an expression, right? It results in the value 20 and you can print that out. Just the character a is also an expression, you can print it out. Function calls are also expressions, right? If we say print 10, we will print out the value 10, right? But print will also return none, which we can then print out again. And here finally we have a more complicated expression, a so-called list comprehension, which allows you to loop through, which is basically an expression alternative to the for statement, right? In this case, do for x in range 2, so you loop through 0 and 1, and then we calculate x times 2. And this is an expression because we can print out the result. So if I print this out, you will see this works, right? Print 20, print a, print 10, and then followed by a none corresponding to the return value of the print statement. And finally, this printing of this list expression results in 0, 2. You see, you can do a lot with expressions. And I'm certainly not advocating that you should never use statements. I think it is practically speaking impossible to not use statements ever. But it is important to be aware of when you are using statements and when you are using expressions, and how in some cases you might make your code more elegant, more functional by using expressions instead of statements. And we will see a lot of examples of this in the rest of this section.